We're going to find a solution or an approximation of our Parmesan cheese jar problem. To start, I go to the internet using Firefox and I'm logging in at www.geogebra.org and I download the app. When you open the app, you will see something like this, and we're going to build the jar in this program. So what I'll do is, by the way, you can change the language by going to options, and you have all kinds of languages here if you want that. Okay, first of all, I would like to start to build this jar, and I choose a segment with a given length. So this is point A, and I choose a length 8, being the diameter of the jar. Now I'm going to put this point on the other side, and I would like to have this horizontal line, so both A and B should have the same y coordinate. Let's have a look. I'll give them the y coordinate -2. I'm almost there. Oops. There you go. And B should have the y coordinate -2 as well, which is now the case. Okay, so next I'll find the middle of this line, and I'm going through the menu, and here, let's see, where was it? Here I'll find the middle of the line, which was there. Between B and A, I have point C right there in the middle. And you can see this also if you look at the coordinates here on the left. Good. Now I need another line for the lid, so I'm going to take a second line with a given length, starting in point A, length 8, and this one will be my lid. You know, I can open the lid. Now I would like to have the handle, and the handle is connected with another intermediate piece of metal here in the middle. Now what I'll do is I want to have this point where both come together. So what I'm going to do is this. I'll choose to draw a circle with a center and a given radius. The center will be C, the radius will be half of 8, being 4. Then another circle will be drawn with D as center. The radius will be 4 times the square root of 2. There you go. And I know where those two pieces of metal come together is, of course, this point of intersection, and I need to define this point of intersection by choosing this function, intersect two objects, this circle and that circle, and E is there the point of intersection. And I'm going to connect those two segments between 2 points, D, E, and C, E. Okay, so what do we have now? I have this point, this segment. Well, let's give it a name and a color. I'll give the color red, and the style, make the line a little bit thicker. So there you have it. That's the handle. This piece of metal, being the connection between the two, make it a little bit bigger and choose a color blue. There you have it. Okay. So now, if the lid is closed, the red handle stands vertical. when I open the lid, you see how far can I go? Well, I can't go any further until this line meets point E, like this. So this is the maximum angle where I can open the lid. So what is now the angle between the position of this red line and when the red line is vertical? So I want to determine that, and how do I do this? Well, first of all, I need here a vertical line. That's easy. You can create a vertical line like, for instance, here a perpendicular line through this point perpendicular to AB, and this line is the line where the position is if the lid is closed. Okay, there we go. And now I want to measure the angle between these two positions. So I have here the possibility to have all kinds of measurements. I choose this one, and then I would like to have the angle between this point, and let's say this point. I first need to define this point of intersection. Okay, there you go. Now I can define the angle, and there you have it. And we see the angle is now at this point 27 degrees and something. Okay, and now let's open the lid as far as possible. There we go, and we will have the answer now in a few minutes, well, even sooner. And that would be my approximation, 55.9368.